Alright, this is part 2 of section 7.1, finding the area between two curves, but this time we're going to be finding it with respect to y. Over the years, students have found this section to be particularly challenging and difficult and bizarre and strange, and they often say they don't get it, it's really hard, but I think the reason they don't get it and it's really hard is because it's a little strange and a little bizarre. So, as we go through, please don't give up on it. Just hang in there. I'll try to do my best to explain either through the video or tomorrow in class as to why we're doing what we're doing. Alright, so for the first example, we're going to go ahead and find the area between the curves, and if you notice, there's some y squares going on. So it's going to produce, if I have a y squared, is a sideways parabola, either a parabola that opens up like this or a parabola that opens up like that. So I'm going to go ahead and find the area. I'm going to have the region that I have in here shown. Alright, so to make a nice, detailed, organized sketch, where they intersect is at -1, +2, and -1, -2, and over here at a 0. Now, if I try to approach this same as before, where I try to find the area that's inside this region, from the last section, the last video, I have to figure out which is the top, which is the bottom. But what happens is, let's look at the second quadrant. In the area in the second quadrant, I have this as the top curve, then I have this as the bottom curve. But once I get past the second quadrant, once I get into, let's say, this region over here, now I have this as the top curve and this as the bottom curve. So I'd have to do multiple regions, multiple integrals, because this is the bottom in this piece, but then over here I have a different top and bottom pieces. So one way to get away with that is integrating with respect to y. Integrating with respect to y. Well, if you integrate with respect to x, that's going to be finding the area going across this way. So sort of like over here. If I want to find the area with respect to x, it's going across like this, going across this way. But finding the area with respect to y means I'm going to be finding the area going vertically, going across like that. And if I'm integrating with respect to y, I have to just figure out which is the area that's on the right, which curve is on the right, and then which curve is on the left. And that's kind of the outline of how to find the area. Is I still have to find the boundary regions, but now I have to figure out which is the right and which is the left function, and then I have to integrate the right minus the left with respect to y. And notice that the limits of integration are going to be the y coordinate, because I'm integrating, I'm shading going vertically this way. Alright, so going back to this problem. Okay. I have to first of all identify the boundary region, so where they intersect. So based on the curve, they intersect, based on the graph, they intersect at -2 for the y coordinate and +2 for the other y coordinate. So my integral is going to go from -2 to +2. Alright. Next thing is I have to identify which is the right function and which is the left function. So which curve is always on the right and which curve is always on the left? Well, this is the right curve and this one is on the left. So this over here is the right, and this over here is the left. And now I have to integrate. But I have to integrate with respect to y. So what that means is I have to solve, I have to get these equations in terms of y. Well, to get this one in terms of y, that means I have to put it as x equal to 3 minus y squared. And to solve this one, I end up with 4x equal to negative y squared, which gives me negative y squared over 4. And so my integral is going to be set up as the right function, which is 3 minus y squared, minus, and then the left function is going to be minus y squared over 4 dy. So simplifying this a bit, I can say the integral from -2 to +2 of 3 minus y squared plus, let me drop the parentheses here, hang on a second. It's going to be a 3 minus y squared plus y squared over 4 dy. Now, the focus of the video is going to be just on the setup, so I'm not going to actually evaluate this. So the actual numerical answer, we can find this out tomorrow in class. But for now, this is like the setup, so our answer, we'll go ahead and find the answer to this tomorrow in class, because I do want to get to one additional example. So, example number 2 looks like that. So I have find the area bounded by the curve for that one. And again, I have to provide some kind of a graph to this. So this is the graph of it. So at this point, see if you can pause it and see what the integral is going to be set up like. If you don't want to pause it, then I can just go ahead and go through it. Alright, so first piece, we have to figure out the boundary of the region. So where they intersect with respect to y is at -1, and they also intersect over here at 2. So they intersect over here at -1 and 2. So it's going to be limits of integration, -1, +2. Then I have to figure out which function is on the right and which function is on the left. So the straight line is always to the right of the parabola. So this is the right function, and this is on the left. And then the last piece I have to do is integrate with respect to y. This one's already solved for me. This one, to put it in terms of y, is going to be y squared minus 2 is equal to x. So then my integral is going to be the right, which is y minus parentheses y squared minus 2 dy. So simplifying this, it's going to be -1 and 2. So y minus y squared plus 2 dy. And again, I'm not going to integrate this in this video. I'm just going to go ahead and do this tomorrow in class. I'll put the numerical value in here, and I'll show you how maybe you can punch this up on your calculator, or maybe we can do this by hand. But the focus of the video is going to be on the setups. If you need clarification, which I'm sure some of you guys might, which is understandable, it is a bizarre and strange departure. I'll go ahead and explain it tomorrow as to why we have to set it up the way that we do. And that is all for this video.